Okay, so question number 14. What is the Lewis structure of sulfur trifluoride that has a negative charge? Okay, so first let's count out the total number of valence electrons. So sulfur contains 6, and a fluorine atom contains 7. Since there are 3 of them, we multiply this by 3. And the overall ion has a -1 charge, so this means we're going to add an additional electron. And if we add all the values up, we should get a total of 28 valence electrons. So now let's draw our sulfur as the central atom and draw single bonds to our fluorines. So if I fill out all the lone pairs on fluorine and count out how many electrons I've drawn so far, if each bond contains 2 bonding electrons, then I've only drawn 24 electrons in this structure. So I need 4 more electrons. So I'm going to add the last 4 onto my central sulfur atom. So now let's calculate the formal charges of all of our atoms. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. For one of the fluorine atoms, since they're all the same, each fluorine atom has 7 valence electrons. All of them have 6 non-bonding electrons. And they're all single bonded, so we have 2 bonding electrons divided by 2. So 7 minus 6 minus 1 is 0. So all of the fluorines don't have a charge. And now let's do the same thing for our sulfur. Sulfur has 6 valence electrons, and there are 4 non-bonding electrons, and there are 3 bonds to the sulfur, so we have 6 bonding electrons divided by 2. So 6 minus 4 minus 3 is -1. So now we know that the negative charge comes from our sulfur atom. So this is the Lewis structure for SF3-. So now let's see what the junior tutor said. Sulfur trifluoride is composed of 1 atom of sulfur and 3 atoms of fluorine. It is considered as an unstable molecule because it has an unpaired electron. Each surrounding fluorine is attached to the sulfur by a single covalent bond. And for the Lewis structure of this compound, the first thing we need to do is to calculate the total number of valence electrons. So they calculated it to be 28, and therefore the compound has a 28 total number of valence electrons. Since sulfur is less electronegative, they'll put it as the central atom, and by obeying the rule of octet and distributing the total number of valence electrons around each element, we'll have the following Lewis structure. Okay, so this solution is correct. And I'll also just note that, however, the sulfur will have a formal charge of -1. So it's not shown in the diagram, but I'll still say that this solution is correct and just add my little note.